Okay, pre-recorded session for exercises. We start with number 32. If you remember in the last session, we did an extra where we took two species of acid and a base of different concentrations وطلعنا كيف فينا to find the pH and the species of the solution based on these. Number 32 part A is the same as the extra that we solved. However, you have different concentrations من اللي نحنا سويناهم. Okay, so basically you have 0.1 mole coming from NH4Cl and 0.05 moles for CH3COO&H4. So when you separate them, the total number of mole of NH4 plus in your solution is basically 0.1 plus 0.05. You know إنه ال NH4Cl خلينا بس NH4Cl is a salt that will completely dissociate into NH4 plus and Cl minus. Okay, 0.1 initially disappears completely to become 0.1 هون و 0.1 هون. So in your solution you have 0.1 molar NH4 plus. هون بعد ما أخذنا we disregarded any type of dissociation لل NH4 plus into NH3 plus H3O plus. When you're working under the assumption إنه بعدنا initial, nothing happened to the solution, you're only combining your mixture. And the second one, which is CH3COO&H4, also is a salt that dissociates completely into CH3COO minus and NH4 plus. So this was initially 0.05 that completely disappeared to yield 0.05 and 0.05. Pay attention إنه I'm working according to the molar ratios أو molar coefficients أو molar counterparts. Okay, so in your solution وبعدني عم بشتغل initially in your solution the species that I have is basically NH4 plus equal to 0.1 plus 0.05 اللي هي 0.15. Okay, and CH3CO minus is basically 0.05. You have a weak acid and a weak base of these concentrations. Again, you do the same analysis that we did before. Okay, exactly the same analysis where you say, okay, different concentrations خلينا نقارن ال Ka and ال Kb. If ال Ka نرجع لهون is greater than 100 Kb, then neglect the base and the reaction and stick with the acid. But if Kb is greater than 100 Ka, neglect the acid, consider the base اللي هي 2. Okay, if Ka and Kb are close to each other, then establish a relation or a reaction between the acid and the base. نفس الشغل اللي اشتغلناه بالأكسترا you have to repeat هون. The only difference is that نحن بالأكسترا we were working with 0.1 molar of NH4 plus and 0.05 molar of CH3CO minus. The only difference إنه هلا ال NH4 plus you will be using 0.15 molar instead of 0.1. That is it. So what you can do is you repeat the entire question. نفس الشيء that I did. Okay, so you start with the reaction, establish the reaction home, and we know why we established this reaction because basically the Ka of the acid NH4 plus and the Kb of the base CH3CO minus are not 100 apart. Okay, they are a little similar. H3 plus CH3COOH. رجع للجيفن حتى ما تضيعوا. ال pKa لل NH4 plus is 9.25 and pKb لل base is 9.25. They have basically the same Ka and Kb, so they have equal strength of acidity and basicity. So you have to establish a reaction with Kr. And you start 0.15 minus x بس لحتى أقدم شوي الآيباد. Okay, and 0.05 minus x أكيد initially. Okay, this is the change, and plus x we already found KR in the previous part اللي هي 4.5. The previous part is a part that was given by me مش موجود بالbook. So now the KR is basically equal to x squared divided by 0.15 minus x be 0.05 minus x, which is equal to 10 to the negative 4.5. Find x. Very simple. I think your x will be around 4.9, 4.8 times. Okay, one number is not enough. One number. Take three numbers after the point, that's better. Times 10 to the power negative 4 molar. This is your x. From your x, you can find the concentration of NH4 plus. You can find the concentration of NH3. You can also find the concentration of CH3CO minus 0.05 minus x. You can find the concentration of CH3COH x. By the way, x normally will be small because look at KR. This is known, okay? And you can also find the pH of the solution with Henderson-Hasselbalch. Either use NH4 plus or a CH3CO minus like we did above. And basically you get that the pH is equal to the pKa. خلينا نشتغل in terms of CH3CO minus plus log CH3COO minus divided by CH3COOH. And basically this is equal to CH3CO minus 0.05 minus x, which is approximately equal to 0.049. This is equal to x, which is approximately equal to 4.8 times 10 to the power negative 4 molar. pKa 4.75, and find pH. Okay, find pH. That's it. Good. Go back to number 32, part B. In part B, you have 0.2 molar of H3PO4. You have 0.2 mole of KCN in 1 liters دغري خلص mole per liter plus 0.05 mole of CH3COH. You have to determine أول شيء the reaction that's taking place, then the concentrations, and then the pH of the system. So you start by putting all your species on the pKa axis. So part B. Let's start with part B. Establish the pKa axis. To establish the pKa axis, we need to write down all species. All species. Our species that we have is H3PO4 and its conjugate is H2PO4 minus. Okay, tiny species that we have Ka, according to the Ka, أكيد pKa is CH3COOH and CH3COO minus. This is the pKa. Okay, the third species that we have is خلينا نقول HCN. CN minus. However, for me, I always prefer that if you have a triacid, put all its species. For example, H3PO4 also has H2PO4 minus, HPO4 2 minus, and you, even though they don't exist in the given ما بيأثر, and it's HPO4 2 minus, PO4 3 minus. لأنه at the end you're gonna highlight what you have in your given. If I go back to the given, the given clearly states H3PO4 KCN يعني CN minus with CH3COH. Go back, highlight what you have. I have H3PO4, okay, I have KCN, which is CN minus, and I have CH3COH. This is what you have in your given. Think about pKa. The major reaction that will take place, it will be between the strongest base and the strongest acid. That means the highest or the biggest or the largest difference in pKa. تطلعوا this is an acid, this is the base. The predominant reaction will be between Cl minus and H3PO4, not Cn minus and CH3COH. No, this is the pKa difference horn, and this is the pKa difference horn. Remember, Kr he 10 to the power pKa2 minus pKa1. The more difference you have between pKa's, the larger Kr. So the first reaction that will take place will be Cn minus plus H3PO4. Basically, just at the beginning, I will put a double-sided arrow to give you H2PO4 minus plus HCN. Always calculate the Kr of this. Always calculate the Kr. The Kr of this will be, since it is along the gamma direction, pKa less Cn minus اللي هي pKa2 دايما larger minus the smaller pKa1 of H3PO4. Now pKa HCN is given as 9 minus 2.2. So 10 to the power 9 minus 2.2, which is 10 to the power كلنا بنعرفها 9 minus 2.2, which is basically 6.8. Okay, let's write the number quickly by calculator. It will be around 6.31 times 10 to the power 6. Look, so the reaction can be written as this. And then you start working. Initially, كان عندي 0.2 you're working in the same volume اللي هو 1 liter, so 0.2 mole or 0.2 mole per liter is the same thing. At the end of the reaction, since it is a complete reaction, both of them are limiting, both of them will be consumed. You will get epsilon. Epsilon is never zero, it's always approximately equal to 0, okay, and 0.2 molar. That's it. You don't have to calculate anything. Then you ask, species present. That was the first reaction taking place. What if there's another? Now Cn minus is not considered anymore. I know it's completely consumed. H3PO4 is also not considered anymore because it's completely consumed. But two new species have appeared. H2PO4 minus now has a value of 0.2 molar, and HCN now has a value of 0.2 molar. And don't forget the H2PO4 minus exists in 2 places. So, what are the possible reactions that can take place here? So, in all of these possible reactions, you actually have acids and one base, which is H2PO4 minus. Okay? Basically, it's considered as a mixture of a weak acid and a weak base. But all of the species, if they have to react, if you have to react CH3COH with H2PO4 minus or HCN with H2PO4 minus, you will have an anti-gamma reaction. So all of the reactions will be limited. Let's find the reaction that is least limited, more advanced than the second. Let's go. Now, reaction 2 that can take place is CH3COOH with H2PO4 minus, okay? And I know this is an anti-gamma reaction, and I know it will be limited. Or it's HCN plus H2PO4 minus. Anti-gamma, it means Kr will equal 10 to the power small pKa minus a large. Small pKa minus a large. So it's basically 2.2 for H2PO4 minus 4.75 for CH3COH. رجعوا أكيد للgiven that they gave you. Okay? The second Kr is HCN with H2PO4 minus. Again, 2.2 minus the HCN is 9. This will be a value of 10 to the power negative 3, around 2.81 times 10 to the power negative 3. This will be a value of 1.58 times 10 to the negative 7. This is the reaction that you study. Okay, لأنه negative 3 is larger than negative 7. So this is the reaction that you now study. How do you study it? Very simple. نكتب الرياكشن CH3 COOH. Let's do this. With H2PO4 minus double-sided arrow أكيد. Okay, to give me CH3 COO minus plus H3PO4. And you start. CH3COH is basically 0.05. H2PO4 minus is basically 0.2. Nothing. I didn't have a value. So 0.05 minus x, 0.2 minus x, x. Find x from Kr. To x squared divided by 0.05 minus x, 0.2 minus x. Okay, find x is equal to 4.91, just check the answer, times 10 to the power negative 3 molar. Okay, and find the pH either from CH3COH or from H3PO4. الهندرسون Hasselbalch of either one or the second. It doesn't matter, but the most important thing that you need to remember is do not neglect x home, because the Ka or the Kr is not small enough to neglect x. Remember, neglect x إذا وصلت ل 10 negative 4 وأقل. If you are larger than 10 to the power minus 4, أكيد 10 to the power negative 4, I prefer that you do not neglect x. Okay? Anything between 10 to the negative 4 and 10 to the 4, do not neglect x. So now I have x, the pH. You can use H3PO4 equals to the pKa plus log H2PO4 minus divided by H3PO4, and this is pKa, one of the couple, 2.2 plus log. How much is H2PO4 minus 0.2 minus x? How much is H3PO4 x? Do you already found x home? You have x, okay? And the pH will approximately be 3. خلينا ناخد الvalue, the actual value, which is 3.79. It's an approximate of 3.8. And that is number 23. Remember, you can also find all the species present, okay? All the species present, you can find it. You can find CH3CO minus, اللي هي X, you can find H3PO4, you can find H2PO4 minus, K plus, you can find HCN. All the species, even the epsilons, you can find them from the Ks. Number 33. Determine the pH of a solution obtained by mixing 100 milliliters of ammoniac. Ammoniac is basically NH3. It has a concentration Cb, it's unknown, with 100 milliliters of nitrous acid, HNO2, of concentration Ca in each of the following cases. Now, pay attention. HNO2 is weak, NH4 plus and NH3 is also weak. Both of them are weak. Okay? So we have a reaction between the base NH3 and the acid HN2. You can put it on a pKa scale. Honey, it doesn't matter. There's only 2 species and they have to react. The reaction has to be HNO2 plus NH3. Okay, it has to be between those two أكيد to give you the conjugates, and KR has to be according whether they are along gamma or against gamma. Now if you imagine the pKa scale, you will see that NH3 will be higher in pKa and HNO2 will be lower in pKa. So NH3 is the stronger base, HNO2 is the stronger acid. It will be 10 to the power 9.2 minus 3.2. If you need to put the pKa scale. Okay, 3.2, 9.2, NH4 plus, NH3, and it's NO2 minus, HNO2. These are the two that you have in your solution. The reaction will definitely be along gamma. Okay, it is easier to start to imagine it. The highest pKa will be the strongest base, lowest pKa the strongest acid. If the reaction takes place between the stronger acid and the stronger base, it means that the reaction is along gamma. Very easy. And that is your KR أكيد. Simply just do the reaction and find the species. خلينا نسويها. يلا, number 33. In number 33, أكيد part A, I have NH3 plus HNO2 in a complete, because we already found that the KR is around 10 to the power 6, NH4 plus NO2 minus. We start. Initially, the volume in this case changes. انتبهتوا؟ 100 milliliters of ammoniac plus 100 milliliters of nitrous. It means that the total volume is 200. Either find the new concentration. كيف بلاقي new concentration? V times C divided by the total volume, or work with the millimoles. ما بدنا نضلنا ننبه على هذا الموضوع. Okay? So NH3 is basically 6 times 100, 6 millimoles. Okay, HNO2, what was the concentration given? مفروض نفتحها قدامنا. HNO2 هي Ca, it's 2 times 10 to the power negative 2, okay, times 100. So basically it's 2 millimole. At the end, this is a complete reaction. The limiting will tend to 0, يعني it will be a value of epsilon, approximately 0. Okay, 6 minus 2, this will be 4 millimole. 2 millimole produced. 2 millimole produced. What's happening? Okay, very easy. Very easy. How can you find the pH? You can use Henderson-Hasselbalch. Of honey, it's easier to use Henderson-Hasselbalch لل NH3. Remember. Okay, why? Because you have a value of epsilon. If you want to use HNO2, you have to find this epsilon. How do you find it? From KR. You calculate this epsilon. It will be very, very, very small. But why do it the long way if you can do it the smarter way? So pH is equal to pKa plus log NH3, which is the base, divided by NH4 plus, which is the acid. And it's equal to what? 9.2? 9.2 plus log NH3 هي 4 NH4 plus 2. ضروري نقسم على total volume? No, it's not necessary, because the total volume above and the total volume below will cancel, and you don't even have to change from millimoles because the units will cancel. It will be basically log 2. Okay, and I think the pH will be around 9.5. And you should get the same answer from both. In part B, you have the same question. Let's write it. NH3 plus HNO2 to give NH4 plus NO2 minus. The only difference is I think this time the concentrations are both equal. 2 times 10 to the power negative 2. Okay, so initially this is 2 millimole, 2 millimole. Okay, both of them are limited, so this is a value of epsilon or absolute zero, approximately zero. This is a value of epsilon. This will be 2 millimole. This will be 2 millimole. Pay attention, you have a solution that contains a weak acid and a weak base of equal concentrations, and the acid has a pKa of 9.2. The base has a pKb. أنا بدرس ال pKb للبيس. Which one is the base هون؟ هلا صرنا عم نشتغل بال NO2 minus. ال pKb of the base is basically 14 minus 3.2. So that is what? 11.8. 11.8 to 9.2. It's a little similar, okay? We can simply say لأنه بعدنا هون بالacceptable range that the pH is equal half to the pKa of the first one plus the pKa of the second. pKa of NH3, which is 9.2, pKa of HNO2, which is 3.2, divided by 2, you get 6.2. Okay, no, I think في فرق أكبر من 2. I did what? Oh, this is not 11.8. Okay, this is 10.8 because the difference has to be around 2. Okay, the difference has to be less than 2. And that is number 33. Let's go to number 34.